and welcome to Applications Manager's free training series. Thank you all for taking the time out and being here. Let me walk you through the topics we'll be covering today. I'll be showing you how Applications Manager tracks and monitors the key performance indicators in AWS and Azure. Secondly, we'll be talking about how you can monitor your Kubernetes container orchestration platform and the important metrics that you need to monitor to gain insight into the underlying operations. Thirdly, back to cloud technology, we'll be seeing how you can track the performance of your Microsoft Teams application. And lastly, we'll be talking about our advanced analytics feature, which is both AI-based and uses machine learning to get the reports. Before we go in depth about the core topics for today, let me give you a brief introduction about the cloud in general. The cloud movement started garnering attention in the early 2010s, and the market has grown exponentially ever since. Now, let's take a look at some of the statistics. Gartner had conducted a survey recently and has concluded that the global end user spending on cloud would be about $396 billion by the end of 2021 and $482 billion by 2022. In 2020, users had spent about $270 billion. Now, that's an unbelievable growth rate. Previously, it had predicted that the spending would be around $330 billion in 2021, and it has exceeded that by more than $65 billion already. If this trend continues, we may very well exceed $500 million by the end of 2022. And if the pandemic and the remote work culture has taught us anything, it's how dependable cloud actually is and how much we've grown to depend on it. One of the main reasons that organizations are lining up to adopt a cloud strategy is how easy it is to migrate to it. In traditional data storage methods, the amount of data stored is directly proportional to the physical space it occupies. But that's not the case with cloud storage. You can store any amount of data without worrying about how much you have to scale, not only physically, but virtually as well. This technology is incredibly flexible and scalable. It allows you to scale new resources quickly, control workloads, gain visibility into critical processes, and ensure seamless end-user experience. It also provides an easier and a more systematic approach to handling workloads. But even though cloud offers a myriad of benefits, it comes with a few challenges such as difficulty in configuring and mapping dependencies, limited visibility, and lack of control. Cloud applications can be dependent on multiple cloud and on-premise technologies. They may even be dependent on hundreds of elements, and discovering and mapping those elements is quite tricky. Some of these elements in the cloud architecture are complex, and visibility into them is often minimum. And lower the visibility, the lesser control you have over the output. Sometimes unscheduled downtime and increase in application latency can occur. Consider this scenario. You want to perform an action which consumes a lot of data. This would make it both time intensive and complex. But now you want to perform another action which has to wait until the first action is completed, since it uses the same resources. And since cloud applications are mostly asynchronous in nature, it would result in a deadlock situation, which causes the application to slow down. In a worst case scenario, it may result in server crashes, thus inducing downtime. Companies could lose their reputation and millions if they encounter this situation. And since the visibility into cloud structures is low, it becomes harder to troubleshoot and optimize the performance unless a third party is involved. Now, this third party is the monitoring tool which helps you overcome these challenges. And that's exactly what ManageEngine Applications Manager does. So how do we monitor the cloud apps and containers in Applications Manager? As you know, Applications Manager is an infrastructure and a server monitoring tool, which also provides application performance monitoring on the side. It offers monitoring for over 150 technologies, including databases, cloud, servers, and other infrastructure elements. It also automatically discovers the applications and maps their dependencies. Going back to the same scenario, Applications Manager's fault management feature identifies the root cause of the element causing the application to slow down, which in this case is the first action exhausting all the resources. If you're already aware that the first action is causing the slowness, continuously monitoring would help optimize the performance. You also have threshold and anomaly profiles, using which you can set the baselines for the metrics, and monitoring them would make you optimize the performance. Applications Manager monitors all the popular cloud technologies such as Amazon Web Services, Microsoft Azure, Google Cloud, and Oracle Cloud, along with containers such as Kubernetes, Docker, OpenStack, and OpenShift. But today we'll be focusing on the two most popular technologies, which are AWS and Azure. First off, Amazon Web Services. Applications Manager collects the metrics for the Amazon Cloud Services through Amazon CloudWatch. It makes use of the appropriate APIs for different services to collect the data, which is then aggregated and compiled using AWS SDK. So these are some of the APIs which is used to collect the data from these services. And this is the API which is used to collect the data from Amazon CloudWatch. Applications Manager collects all these data and aggregates them into a form that is both easy to interpret and understand. The Applications Manager monitors the following services in Amazon Web Services. You might have gotten a rough idea about the services monitored from the previous slide. So we have provided monitoring for compute services, containers, databases, load balancers, storage, notification service, queue service, and billing. So let me go to the console and show you how you can add Amazon Web Services to be monitored in App Manager. So by clicking on New Monitor and Add New Monitor, you'll see all the monitors that you can add. And under Cloud Apps, click on Amazon. So before adding the service, you need to make sure that the prerequisites have been fulfilled for AWS Monitor. So you need to fill all these fields, and all the Amazon services are listed here. Based on your requirement, you can remove the services that you do not require. You have to specify the access key ID and the secret access key, along with the account type and the polling interval. You can choose to associate this monitor to a monitor group too. So you can also configure how you want to collect the data. So simply go to the admin tab and click on performance polling. And under the performance polling, click on Amazon, and you can select your desired options. You can choose to whether or not you want to get an alert for a terminated EC2 instance. You can choose to remove the terminated EC2 instances, Lambda functions, remove the terminated Elastic Beanstalk environments, deleted DynamoDBs, Elastic load balancers, and inactive ECS clusters. You can also choose to collect S3 storage statistics with the help of a CloudWatch API. On modifying all these Amazon services, you can choose to stop discovering or delete the service as a whole. So let me show you the KPIs and the metrics that you can monitor with Applications Manager. Go to the Monitors tab and click on Amazon under Cloud Apps. When you click on Amazon, you see the following tabs labeled Compute, Containers, Database, ELB, S3 Buckets, SNS, SQS, and Building. So the Overview tab provides a general overview of all the services that you can monitor in Applications Manager. As you can see, you have the compute resources, storage resources, which has the EBS volumes, and S3 buckets, database resources, application integration, and containers. By clicking on compute, you can see that we monitor the EC2 instances, Lambda function, and Elastic Beanstalk environment. So Applications Manager discovers all the EC2 instances globally and lists them here. By clicking on any one of the instances here, you will be able to view a granular data about that instance. So the Overview tab provides a general server snapshot of the instance. It provides you with the CPU utilization details, network traffic, and disk I/O. So you can also monitor the OS level metrics. But in order to collect the OS level metrics, CloudWatch agent must be deployed inside the EC2 instance. The key Metrics that you need to monitor in EC2 instances are CPU utilization, status of the instance, and disk rewrite stats. So you can also monitor your EBS volumes, and the important metrics that you need to monitor here are volume versus idle time, which tells you whether your volumes are inactive and unused, or volume versus read and write latency, and a volume versus read and write throughput along with the queue length. So going back, looking at the Elastic Beanstalk environments, the important tabs are latency, requests, where you can get the total response summary, the top 5 instances with maximum requests and error requests. And also instances are the most important metrics that you need to monitor. Another important metric that you need to monitor is the events. So you can specify how many events that you want to monitor by going to the admin tab and clicking on performance polling. And under performance polling, instead of going to Amazon, you go to optimize data collection and select the server. And by selecting the server, you get the metric name, which is events here, and you can specify the number of events that you want to fetch after every polling, which is 20 by default. Going back, let's go to the containers. So Applications Manager monitors two types of containers. One is Elastic Container Service, which are the Docker containers which have been deployed in the cloud, and the other one is Elastic Kubernetes Service, which are the Kubernetes containers deployed in the Amazon cloud. Both of these are integrated tightly with EC2 and Fargate instances. So I'll be talking about Elastic Kubernetes Service when we get to the second part of this series. So we'll take a look at the Elastic Container Service clusters now. So you get an overview about the clusters along with the cluster tasks and cluster services. And the important metrics that you need to monitor here are the memory utilization, CPU utilization, which is given here. And also, when you go to the services tab, you need to monitor the running tasks and the desired tasks per service. And if the running tasks are equal to the desired task, it means that the service is healthy. And if they're not, it means that the service is unhealthy. So going back, we have the database tab in which we monitor the RDS instances and the DynamoDB tables. Under DynamoDB, the important tabs that you can monitor are the read-write operations, table errors, and global secondary index, along with streams also. So the streams give you the request latency, returned bytes, returned records count, and etc. So Amazon Relational Database Service enables users to provision and operate RDBMS in the cloud and can be deployed on widely used database engines such as MySQL, Oracle, MS SQL, PostgreSQL, and MariaDB. You can also monitor Aurora database, which is both Postgres and MySQL compatible. So clicking on Aurora DB instance, the important metrics that you can monitor here are disk IO, which is listed here, along with the cluster volume IO, volume usage, and the network details, the Aurora DP details like Aurora replication lag, database transaction, cache hit ratio, deadlocks, bin logs, disk usage, etc. So another important service to be monitored is the Elastic Load Balancer service. So as you can see, we monitor two types of load balancers, application load balancers and network load balancers. The important metrics to be monitored in the load balancers are connection statistics, latency, and the unhealthy number of unhealthy and healthy host counts, which will be listed there. So moving on to S3 buckets, you can see the S3 storage statistics and the S3 request statistics. In SNS service, you can see the number of messages that has been delivered, number of notifications which have been failed and published along with the message throughput. And in the queue service, only the overview is provided for the queue service along with the performance rate and the breakdown of FIFO messages and processed messages. So going back, the most interesting feature of AWS monitoring in Applications Manager, I would say, is the billing feature, where you can track the amount you have spent on the Amazon Web Services by month to date, which is available in both a graphical format and a tabular format. You can also predict the usage and the expenditure that you will be incurring by using all these services, along with the services and the tax breakdown. So let's go back to the PPT. So up next, we have Microsoft Azure. So in Microsoft Azure, Applications Manager supports various cloud elements like Azure VMs, Azure Service Buses, SQL databases, and storage accounts. It collects all the data with the help of Azure SDK in the form of metrics and events and provides you with a unified view on Applications Manager. It connects with the Microsoft Azure through Azure APIs to determine the health status and other performance counters. It helps you discover the services, monitors the number of virtual machines which are provisioned and running, and helps you view the status and configuration info of the discovered resources. You also get insight into your applications, containers, virtual machines, and you can analyze the historical trends and visualize dashboards. So there are three types of discovery modes in which you discover all the Azure services. Number one is Active Directory and Application and Service Principal, where you have to specify the client ID, tenant ID, and application key. The second one is Azure Organizational Account through PowerShell, where you have to specify the user email, password, and the verified domain name associated with your organization. And the third one is the OAuth, where you have to specify the OAuth provider. So let's go to the UI. So let me show you how you can add the Azure monitor simply by clicking on Add New Monitor and clicking on Microsoft Azure under Cloud Apps. You will come, this box appears. You have to make sure that the prerequisites are already fulfilled. And by filling all the fields here, you can add the monitor. So you have the discovery mode, which we've talked about before, and by selecting any one of it based on your requirement, and you have to specify the timeout and the polling interval. So the KPIs that you can monitor in Azure Cloud are the metrics related to virtual machines, storage accounts, SQL databases, and service buses. So as you can see, the overview tab has a general overview about the resources and the services that you can monitor, with the total Azure virtual machines provisioned, running, standard storage account, premium storage account, SQL databases, and the namespace count. So going to the virtual machine tab, you have a general overview of all the virtual machines that the Applications Manager has discovered. And by clicking on any of the virtual machine here, you will be able to see the underlying metrics, such as CPU, memory, disk, threads, processors, and services. So the important metrics that you need to monitor are CPU, memory, and disk. So moving on to the storage accounts. So all the storage accounts are listed here, which is divided into standard storage account, and premium storage account. So by clicking on any one of the storage account, you will be able to monitor the storage account. The View tab basically provides you with the availability stats and the configuration stats. And the most important metrics that you can monitor are given under blocks, which has the capacity, throughput, which gives you the total ingress and the total egress, along with the latency and the requests failed because of throttling errors, timeout errors, other client errors, other server errors, other authorization errors, network errors, along with the successful requests. So you get the same information under tables, files, and queues too. So moving on to SQL databases, by clicking on any one of it, you will be able to view the underlying data. So going back to the example about the resource exhaustion, sometimes it can be caused by a query too. So by monitoring the top queries by CPU, which lists all the CPU intensive queries, you'll be able to find out which query has caused the application to slow down. And you can also monitor the top slow running queries, the frequently executed queries, and the most blocked queries. So these most blocked queries are the ones that usually cause the deadlock situation. And by monitoring these, you'll be able to get a general idea about which query causes the deadlock situation, so that you can purge it or kill it based on what you want to do. Moving on to the Azure service buses, the important metrics to be monitored are listed on the queue and topics, where you can monitor the top queues based on the incoming requests and also the topics based on the incoming requests. We come to the second part of the series, which is how you can gain insight into your Kubernetes container orchestration platform. So as you know, Kubernetes is an open source container orchestration system for automating deployment, scaling, and management of applications and containers across the cluster of hosts. It's becoming the de facto compute control plane for not only cloud native, but also on-premise applications as well. It offers a built-in implementation for both internal and external load balancing. So a fun fact about Kubernetes is the reason why it's also called as K8s is because it has 8 letters or alphabets in between the letters K and S. So let's talk about the architecture now. So Kubernetes contains clusters, which consists of a set of worker machines called as nodes, which runs the containerized apps. Every cluster has at least one node. And the nodes host pods, which contains one or more containers, which share the same resources. So the persistent volume is a storage element provisioned by an admin or is dynamically provisioned using storage classes. And the service is an abstract way to expose an application running on a set of pods. So what are the key metrics that you can monitor in Kubernetes using Applications Manager? The metrics related to nodes, pods, services, and persistent volumes are the most important metrics that you need to monitor in Kubernetes. And you can also monitor that in Applications Manager. Going to the UI, let me show you how you can add the Kubernetes monitor. Go to Kubernetes under virtualization, fill out all the fields, and you can either choose to use a public key authentication or use the normal authentication. So if you choose the public key authentication, you need to give the username, private key, passphrase, and prompt. And you can choose to monitor specific namespaces, and you filter it based on any condition, whether to include the following namespaces or exclude the following namespaces. You have to specify the timeout and the polling interval and click Add Monitors. So the KPIs that you can monitor in Kubernetes is listed under virtualization, and you have the following tabs in Kubernetes, which are nodes, pods, services, and persistent volumes. The overview gives you a basic overview about the namespace, pods, top 5 nodes by use pod count, cluster usage details, and component details. By clicking on the node, you get the node details, and the important metrics that you need to monitor are the memory statistics and the CPU statistics. Also, you need to monitor the node pod details with the pod usage details. And under pods, you get the details about the pods, like the pod created and the status of the pod, and top 10 pods by memory, along with the CPU also. You have that in a tabular format as well. So you also have the services details and the persistent volumes details. So you need to monitor the services and the deployment, because the deployment is responsible for keeping a set of pods running, and the service is responsible for enabling network access to a set of pods. So that is it about Kubernetes monitoring with Applications Manager. Moving on, how you can track the performance of your Microsoft Teams application. So Microsoft Teams is a business communication platform which is offered as a part of Microsoft 365 suite. It entered the business chat market in 2016 and has over 145 million users currently. In 2020, it had 95 million, and the pandemic has propelled it to its success. It's one of the fastest growing apps. So the reason why people choose Microsoft Teams is because of its ability to chat and call easily, host meetings, store attachment, easily share and collaborate, and integrate with other Microsoft applications. So this is how a Microsoft Teams chat program is divided into. A channel is where you talk with another person on the Microsoft Teams chat platform, and you have the following conversations, files, notes, and connectors, which can be monitored using Applications Manager. So by with the help of Applications Manager's Microsoft Teams monitoring feature, you can view the detailed metrics into the health status of the services, track the connectivity status and response time, and you get that in a single console. And you can also track the team members and the channels in the organization, and get the usage information based on device and activity type. Let me show you the metrics that you can monitor in Microsoft Teams using Applications Manager. So you have it under Microsoft 365, and by clicking on the entry, you can see the overview, which provides you with the Microsoft Teams service health and endpoint connectivity. You can monitor the response time of the endpoints, and under teams and channels, you can monitor the channel count and the member count in each team. And in the channels, you can monitor the member count. Or you can also monitor the devices on which it is used and the number of users based on the device type, and also the user count based on activity type, and the activity count based on the activity type. So that is it about Microsoft Teams application. Moving on to the machine learning enabled analytics for cloud applications. First up, you take a look at the forecast reports, which gives you a predictive analysis for the growth and utilization of various metrics. And it helps you track the variations in the current stats, and it works based on machine learning. Like I said, you can track and predict it by either growth trend or by utilization. So I'll show you the reports that you can generate for the cloud applications. So you can either get it in a monitor group like Cloud Apps. By clicking on it, you get an at-a-glance report, and you also get the response time of the Cloud Apps and availability along with the health reports. So an at-a-glance report contains all the metrics that you can monitor. So if you want to monitor or analyze a particular metric, you go to the select attribute and select any of the metric. For example, I'm choosing this utilization in percentage. So when you choose it, you get the top 10 EC2 instances based on the disk utilization percentage. And by clicking on any of the filters, you can filter it for the top 10, top 20, and top 50. for any of the periods, like for today or yesterday or this week. So moving on to trend analysis report, you also get the trend analysis report. And by clicking on any of the monitor, you can monitor the trend analysis. For example, the CPI utilization in percentage. Here you get the history report along with the details, hour of the day report, week of the day of the week report, statistical report, and heat chart. You can choose the business hour also, and you can export it in a PDF or a CSV format. So the most important type of report, which is the forecast report. And by clicking on the cloud apps and selecting an option, so disk utilization, you get the forecast by growth trend and the forecast by utilization. And you can predict the usage for up to 3 years into the future. And by clicking on any of the instances, you can view the underlying details and how Applications Manager predicts the growth trend and utilization, which is given here along with the actual data and the forecast data. So that is it about forecast reports. So these are the at a glance report where I told you it will provide you with all the metrics so that you don't have to go to the metrics separately. So moving on to capacity planning reports, it helps you evaluate the future growth and tracks the resources like CPU, memory, and disk. You can right size your machines by finding out which machines are oversized, undersized, and idle. Let me show it in the UI. So under capacity planning, you have the virtual machines for Azure services. So you can see that there are undersized, oversized, and idle machines. So you have all the virtual machines listed here and the condition on which it has been configured for. So the Azure virtual machines are supposed to be undersized if the percentage of time is greater than 50%, and all of them have not been satisfied, so they are not undersized. So based on this, you can right size all your virtual machines and servers. Today, we've seen how you can monitor your Amazon Web Services and the Azure infrastructure and the important metrics that you need to monitor in each of these cloud technologies. And you can also monitor all the services listed under the AWS and Azure cloud technologies. Secondly, we saw about how you can monitor your Kubernetes container orchestration platform and optimize the performance by monitoring certain metrics. And thirdly, we saw how you can optimize the performance of your Microsoft Teams application by monitoring the channels and the teams, and along with the devices that has been used in the activity type. And lastly, we saw how you can use our analytics reports to enhance your performance by analyzing and forecasting the resource usage and growth. Thank you all for tuning into today's session and staying till the end. I hope you all have a good day. And until next time, this is Angie signing off.